Today's experiment centers around the physical separation of components of a mixture. And all that really means is we're going to make a mixture of three different species: ammonium chloride, sodium chloride, which is just salt, and silicon dioxide, which is sand. We're going to make a mixture of those three things. And we're going to use physical rather than chemical means to separate those components of the mixture out from one another, one at a time. We do this by using thermal and solubility properties of these three species. So you'll make your mixture in a dish, and then you're going to heat that dish over a Bunsen burner. And I'll go through a short demonstration of how to do that and how to operate a Bunsen burner here in a moment. As you heat the mixture up here, as you heat it, the ammonium chloride will sublime. That is to say, everything is going to be solid when you make your mixture initially. You're going to have solid ammonium chloride, solid sodium chloride, and solid silicon dioxide. As you heat the mixture, the ammonium chloride will begin to transition from being a solid to being a gas. So it goes from solid phase to gas phase. We call that sublimation. There's no liquid phase in between. It goes directly from a solid to a gas. That's called sublimation. So what we'll do is we'll take the mixture and we'll sublime the ammonium chloride. That drives it off. That separates it. And what you have left behind is the sodium chloride and the silicon dioxide. Okay. At that point, we'll then add water to the dish. Now, the salt is water soluble. The sand is not. So what you'll see is the salt gradually goes into solution, and you end up with a dish that has a layer of salt water sitting over top of a layer of just sand in the bottom. To separate the salt, all we'll have to do is pour that salt water off of the sand. So we have a dish, we have a layer of sand at the bottom, and then over top of it we have a layer of salt water. We will pour off, which is what decant here means. We will decant the salt water into a second dish. Okay, that salt water, after it's undergone the process of decanting, we call that salt water the decantate. So we'll have our decantate in a second dish, which we'll then heat. So we'll heat the sodium chloride solution in the second dish. And what will happen is the water will evaporate, and what you get left with here will be just dry salt crystals. And so now you've separated the salt from the sand as well. At that point, all that's left is we're going to take the wet sand that we left behind in the first dish, and we're going to heat it as well to drive off the water left behind with it. And so the idea here is that we've separated all three of our components. We're going to weigh everything and see if the weights of the separate components add up to the weight of the original mixture that we started with. On the screen you should see what is called an implement called an evaporating dish. And I've got it situated on the metal part of a balance. Now, in a previous video I've already discussed how to read one of the balances in this lab, so I'm not going to go over that again. But I've got this set here because I want to quickly demonstrate how to use a spatula to weigh out a certain amount of a solid that you may be working with. So the mixture is comprised of three solid species. Again, it's ammonium chloride, sodium chloride, and silicon dioxide. So what you'll do is put your empty evaporating dish on the balance, just like I have it here, and you take the weight of your empty evaporating dish, because this dish right now is empty. So then what I'll do is I'll zero the scale. If you remember in the previous video I talked about the tare button. So I'll use the tare button to zero out the scale. And then what I'm going to do is I'm going to take the first component of my mixture, which is the ammonium chloride, just in a nondescript amber bottle like this, ammonium chloride. And I'm going to use an implement called a spatula to measure this out. Now, the lab manual gives specific ranges that you're supposed to use with each of your three components. It specifies between 0.2 and 0.25 grams of the ammonium chloride. So I'm going to open my bottle. I'm going to take my spatula, just like this, I'm just going to insert it, and I'm going to maybe break up. Sometimes it kind of forms into chunks, so you have to break that up. Anyway, get a nice spatula full of my powdered white ammonium chloride. And what I'm going to do, it's really easy to put small amounts of this into the evaporating dish. It's really hard to get small amounts out. So you really don't want to overshoot. The easiest way to do that is to take your finger like so. And I've got my spatula at a little bit of an angle towards the evaporating dish, and lightly tap, just like that. And you can see a little bit of the ammonium chloride being deposited in the evaporating dish. Every time I tap like that, as I just keep kind of tilting it a little bit more, I get a little bit more of the powder. So okay. So right now I'm at 0.239 grams of the ammonium chloride. So that's what I'll record. When I go to add my second component here in a moment, I'll just zero the scale again. Just leave the dish on there just like I have it, zero the scale, and then I'll add my sodium chloride into the dish, same as I did with the ammonium chloride. Just take the spatula and lightly deposit my powder in there, and do the same thing for the third component. So the setup that I'm going to be using to drive off the ammonium chloride is should be on the screen right here. This is a ring stand, and what this allows me to do is to elevate my evaporating dish here over top of my Bunsen burner. And so the Bunsen burner is going to emit a flame. It's a gas jet basically that we light, and the ring stand just ensures that it's placed over the flame so we can heat it adequately. Now it's sitting on, I've got my ring, I've got my evaporating dish. In between the two of them, I've got what's called a pipe stem triangle. Okay, so what I do is I set the triangle on top of the ring stand, set the evaporating dish kind of in the crooks of the pipe stem triangle, and should be set. There's a red tube here that connects to the base of the Bunsen burner, and that's what allows the Bunsen burner to get its gas from a nozzle back here. So the tube is what feeds the burner. The burner will help heat the evaporating dish, and it will drive off the ammonium chloride. As the ammonium chloride sublimes, you should see the formation, like a white gaseous emission coming from the evaporating dish. So I'm going to change the camera angle just a little bit so that you can kind of more adequately see the Bunsen burner as it does its work here. I've already opened the nozzle, and I'm feeding the Bunsen burner right here gas as we speak. So I'm going to light it to start the heating process. This is a striker. Okay, it's just a lab implement that we use to light the burner. When I apply pressure to it, the striker here runs across and creates a spark, which I'll use to light the burner. So that's, I don't know if you can see the, there we go, a couple good sparks there. Sometimes it takes several tries to get the burner to light. These strikers are ancient, and so sometimes it takes a minute to get a good enough spark to adequate to light the Bunsen burner. So I'm just going to put it over the burner, like so. There we go. Okay, and that's my flame. I'm just trying to center the flame a little bit. Now you can already see the evolution of the ammonium chloride gas. You can see this white gas being emitted from the evaporating dish. That's the ammonium chloride subliming. And so what I'm going to do is I'm going to heat this until the gas emission, the gas evolution basically stops. And then I'm going to heat it for about 30 seconds after that, just to make sure I've driven all of it off. And after I do that, I'm going to let the evaporating dish cool for several minutes. If I take a hot evaporating dish and place it on a balance, not only do you risk burning yourself, but it can distort your measurements. When the heat interacts with the surface of the balance, bad things can happen, so we try to minimize that. So I'm going to let it cool. It takes several minutes to cool. You won't be forced to watch all that. And then we'll weigh what's left in the evaporating dish. Theoretically, what's left in the evaporating dish should be the mass of the mixture minus the mass of the ammonium chloride we used, because theoretically we're driving all of the ammonium chloride off through heating. So the only thing we've done is just heated the ammonium chloride to drive it off. The mass remaining should just be the other two components that we started with, since we've done nothing to them, and we'll see if that's the case.